Welcome to Geometry for AP. Today we're going to be doing our first talk on parallel line proof practice. Uh, it'd be good for you while you're doing this video to try to pause the video when you first put the proof up, see what you can do with the proof, and then continue the video on to see how I complete the proof and stuff like that, and see how similar yours is to the proof. Don't erase your work, see how your work is different than my work, and see how they can come together. All right? So we've already learned all of our postulates and theorems for this. So if we look here, here's our first proof. If you want to pause the video and then get ready to do this video, this proof. Okay, so as we look at this first proof here, I'm going to grab my pen. Let's look at the information that we know is true. We know that A is parallel to B. We know angle 1 is congruent to angle 2 because of A is parallel to B. We know angle 2 and angle 3 are a linear pair. And we also know that angle 2 and angle 3 are supplementary. We also know that angle 2 plus angle 3 is equal to 180. And if 1 and 2 are congruent, then I know that I can take out 2 and I can put and make 1 plus 3 equal 180. Well, and that's what I'm trying to prove. So in this case here, let's start with our first little given piece of information, which is A is parallel to B. All right, and so if I have A is parallel to B, and so that's my first thing, and that's given. All right, and then if that's given, then I know that if A is parallel to B, we said over here a minute ago that I can now say that angle 2 and angle 3 are congruent. I'm going to go ahead and put this here too, just so we can see it. That if angle 1 and angle 2 are congruent, then I can say that angle 2 and angle 1 are also equal. And so this is because of the corresponding angles theorem. And this is because of the definition of congruence. And I kind of went with this because we know over here with the information that I had that I was going to have to be able to substitute something in. So in order to substitute, I need to be inequality. And so then if I go back over here from my baseline, we can go into this and we can say, all right, we have angle 2 and angle 3 are a linear pair. All right, and I think I'm going to get out of this so I can pick pins and stuff a little bit faster. So, all right, so 1 and 2 are a linear pair, and that is because of the definition of a linear pair. It says what they look like. And then after I can say they're a linear pair, then I can go say that they are supplementary. Okay? And so they are supplementary because of the linear pair postulate, which says that if I have a linear pair, then they're supplementary. And I know by the definition of supplementary that if they're supplementary, then they can add to equal 180. And so this is the definition of supplementary angles. All right, so now I know 2 plus 3 is equal to 180. I know 1 and 2 are equal to each other, so I can bring these two together. I can take out the angle 2 and replace it with angle 1. And when I do this, I get substitution. And I have proven that 1 plus 3 is equal to 180. And that is our proof. All right. So let's go to our next one. Pause the video if you'd like. Start this proof up. You can see I have some boxes here, so it takes about 5 steps to do this. And so pause your video, see what you can do with this one. All right, so if we look at this information, we have A is parallel to B and C is parallel to D. Now, if A is parallel to B, that's this line and this line, that means I can do something with that information, and I think the only information I can do is angle 3 is congruent to angle 4, because those are the two angles that are created by those two parallel lines and a transversal of D. And then C and D are parallel, and so the only two pairs I can do here are these two, so I can say angle 1 is congruent to angle 3. And I can see a connection here. 3 is in both of those, so that means I could say that 1 and 4 must be congruent by my transitive property. And so we start off here with our givens, all right, which in this case is the only place I have to go. So there's my first one, all right. And so if I look over here, I need to be careful how I write this. I want 1 is congruent to 4. So that means I probably need to start with 1 and 3. And this one's 3 and 4. So if I shift these things around, kind of like this, then that'll be the order I really want to see it in. And so that will be in my transitive order, and that'll make things a little bit easier for me. So, all right, so let's take that one out there. And so these were givens. All right, given, given. All right, and so then this one goes down here. And why are 1 and 3 congruent? 1 and 3 are congruent because they are the corresponding angles theorem. And when A and B were parallel, we had 3 and 4 congruent. Those are congruent because they're the alternate interior angles theorem. And so there's that one. And so then I can bring those both together so that I can say angle 1 is congruent to angle 4 by the transitive property. I didn't have to do any equality here because remember that transitive property can work with the congruent sign instead of the equality sign. Oh, I didn't connect that one. Sorry there. All right, and there's my proof. All right, we go to our next one here. If you want to pause the video, make an attempt at this proof. I always think it's best to list everything that you can prove or know that you know is true. I find that some people just list stuff that they don't even know is true. They're just listing things. You need to make sure you have a reason for each thing that you put over to the side. So pause and try to list what you can do first before you start trying to do your proof. Look at what you're trying to prove and look at the information that's given. All right, so if I look at my information, I got A is parallel to B. So if A and B are parallel, I know angle 1 is congruent to angle 2. All right, and I've got C is parallel to D. So I've got C is parallel to D. Then angle 2 is congruent to angle 4. And I can already see a connection here. So if I've got those two, then I can say angle, whoops, I didn't mean to do that. I can say angle 1 is congruent to angle 4. That's a little transitive property going on already right there, so I can see that. But I got to get 180 into this problem. If I look at this problem, the only place I can get 180 is by the angle 3 and angle 4 are a linear pair. Oops. And then I know that angle 3 and angle 4 are supplementary because of that proof stuff. Now, when you're doing these, it might be good to have those beginning proofs out that we did last week. That can help you. And so then I know angle 3 plus angle 4 equals 180. Now, that's important. I've got the 3 and the 4 in equal 180. Well, if I look up here, I got 1 and 4 are congruent, so couldn't I take out the 4 and replace it with 1? And so angle 3 plus angle 1 equals 180. Oh, that was weird. Equals 180. And so that's what I'm trying to prove. And so I know I've got some substitutions go into here with those, and so let's get into that proof. So first of all, oh, that's my pen is on. All right, so I got A is parallel to B, and I got C is parallel to D, and we said this in our given information. All right, so we go to here, we go to here, and this goes to here and here. And so this was given, this is given, all right? And 1 and 2 are congruent because of the alternate exterior angles theorem. 2 and 4 are congruent because of the corresponding angles theorem. Now, remember that I could bring these together by transitive, so I guess I could have just gone straight to angle 1. Oh, that was weird. Get rid of all this stuff. Angle 1 is congruent to angle 4. So I'm going to here, to here. And then I can say the measure of angle 1 is equal to the measure of angle 4. Now that's kind of a little bit in my way there, so I want to rewrite that a little bit. The measure of angle 1 is equal to measure of angle 4, put a box here. Okay, and so this was transitive property, and this right here is definition of congruence because I want it to be equal. I can't do any substitution without equal sign. And so remember up here we said we had to do the linear pair thing, so that's where I've got my linear pairs in here. And remember, there's always like a little 3-step process here. That was back in those original proofs, remember, that we did last week in chapter 2. Okay, so this is the definition of a linear pair. This is the linear pair postulate. And this is the definition of supplementary. You'll notice these come together all over and over and over again all the time. And so then finally I connect this one here. So I got this one and this one connect because I want to take out that angle 4 and replace the angle 1. And so this is substitution property. All right, list those things that can help you build your proof and look for connections. All right, and this is, I think, our last proof. And so here we want B is parallel to C, and we want to prove that measure of angle 1 plus measure of angle 3 is equal to 108. So if I look here, these two are parallel. So if I look at my given information, B and C. Oh, by the way, you could pause this video right now and complete this proof on your own, and then come back and see how you did. All right, so B and C are parallel. And so if B and C are parallel, then I don't know anything about 1 and 3, but I do know that angle 1 and 2 are congruent because of there being an alternate interior pair. All right, and then that's about all I can do there. I know that angle 2 and angle 3 are a linear pair. I know that angle 2 and angle 3 are supplementary. All right, and then I know angle 2 plus angle 3 equals 180. And so if 1 and 2 are congruent, then couldn't I take out 2 and replace it with 1? So that'd be 1 plus 3 equals 180. And that's what I was trying to prove again. So I got to get that 180 in there. I usually do, anytime your problem has 180 in there, you're going to use the linear pairs to get that in there. Okay? And so then I go here. B is parallel to C, and we said that was going to prove that angle 1 and angle 2 are congruent. But because I have to take something out and replace with something, I need it to be equal with substitution. Okay, so this is my given. The 1 and 2 are congruent because of the alternate interior angles theorem. And this is a little definition of congruence. And so I've got that side set up, and now I go back over to my linear pair. Remember, that's how I get my 180 in. And notice these 3 steps come together over and over and over again. So get used to using them. All right, this is my linear definition of my linear definition of linear pair. And then this is my linear pair postulate. Okay, and then I go to my definition of supplementary. Once I say those angles are equal, or supplementary, then I can say they're equal. And so then I'm going to bring both of these together, because if this and this, then these come together. And I do that because, oops, I still got my pen on. You're on, okay, and then I go here, and that is substitution property. All right, and that's going to wrap it up for our proofs. You'll have something to do just like this. Keep your proofs out, your beginning proofs that we did the video on back for 2.5, 2.6. When you're doing this, it will help you a lot when you're doing these proofs, because that's how these 3 linear pair things come together, vertical angles and things like that. All right, I'd be ready to come to class, and you can start your proofs early if you'd like.